Thank you for the nice introduction. As a bit of context, this talk is basically based on a paper we presented at EuroSMP last year. And the paper was basically a collaboration with SAP Security Research and Ben Stock from CISPA, the old lady of XSS, as he was referred to yesterday. And I'm talking about hand sanitizers today. And if you have basically not lived under some rock, you will have heard a lot of media coverage regarding hand sanitization in the context of the COVID pandemic. And there it was something that was generally very positive. In the web, the picture's a bit more mixed, or it's pretty bad, I would say. And basically, the goal of this talk is to basically explain to you how to do sanitization right, or at least how not to do it, because it's pretty difficult. And this is a talk about client-side cross-site scripting. And basically, client-side cross-site scripting can occur very easily if you have a very dynamic website. Like, for example, if you think about a sign-up page, like you want to invite people and you want to make it personalized. The people enter the name, and you basically transmit the name in the URL. And basically want to echo it back because you don't want to have after login like simply hello, but you want to have maybe hello David. And yeah, code which achieves this could look like this. And basically, if you visit it with RuhrSec as a parameter, you get hello RuhrSec. That's nice. What's also sometimes nice is if you do this, you can also do some markup, like some formatting, which can be a good idea, like if you have a guest book and want to leave comments. So emphasizing a word or making something bold is not something negative, but if you can do markup, you can also do this. And then you have code execution security domain of the website, and you can steal cookies, you can impersonate the website, you basically can do whatever you want. And that's obviously a problem, right? If people enter the credit card information, you can exfiltrate them, that's an issue. Like, you get legal consequences and basically reputational damage. Okay, why does this occur? And the main issue is that in HTML, there's no difference between data, like a name, or string with a name, and markup like the image tag or the bold tag. And for client-side cross-site scripting to occur, you basically need attacker-controlled data entering the application some way. Usually it's in the URL, but there are other forms like cookies, for example, can be used for cross-site scripting. But it's usually in the URL, it's the easiest way. And you need a sync, which is basically a function which takes a string and transforms it into code and executes it. And that's the main issue with the browser, I believe, that there are tons of functionalities which basically do such string-to-code transformations. And it's really easy to basically miss them. And if you then have an unprotected data flow between source and sync, you have client-side cross-site scripting. Yeah, as was already said, in OWASP, this is one of the most basically frequently abused vulnerabilities. And if you want to protect yourself against client-side cross-site scripting, what you would usually do is you would use a sanitizer. You can also try basically CSP that doesn't prevent cross-site scripting, but mitigates it, but nobody can set them up properly. Yeah, Ben had a talk last year, I believe, about CSP, and it's impossible to set them up correctly. And a sanitizer is basically the idea. A sanitizer is a function which takes input, untrusted input, and removes or encodes all dangerous characters from this input. Like user inputs gets in, and a clean string comes out. And yeah, for this project, handwritten sanitizer functions were dubbed hand sanitizer. It was a bit more funny in 2020 when we started this project, and has gotten a bit tired now. And how it would look like that somewhere in your application, you now have the sanitize call, where basically the same data flow as before goes through the sanitizer. And now, after leaving the sanitizer, it's protected and the application is secure. That's great, right? If it was that easy, I wouldn't be standing here, I suppose. The question now is, how would you write such a sanitizer? And I will give a short example in JavaScript. Like here you have a function which takes a string and replaces angle brackets. In the payload I did show, it was an image tag. Without angle brackets, it doesn't work. So it's secure now, right? If we take the payload again, it basically strips the angle brackets and no code execution takes place. Great. However, JavaScript is a bit strange. And if you basically manipulate the payload a tiny bit, like you add those two angle brackets, you get code execution again. This is due to usability issues with the replace function, which is probably one of the most basic standard library functions, I would say. And I will come back to the reasonings later on, but what I basically want to say is writing a sanitizer by hand is really difficult. And this is especially the case because you have different injection contexts. You have either HTML, where you basically could insert a tag, where you could be in an attribute, where you can basically manipulate the attribute, or it could end up in eval. We have JavaScript. And if you're a bit familiar with like JavaScript and HTML, they are syntactically completely different. Like if you basically want to remove characters which are control characters in HTML and in JavaScript, the overlap is fairly small. And yeah, exactly, exploit requires different characters for each injection context. And there's some OWASP recommendation on how you do this, and the list is pretty long. And it's pretty hard to write a sanitizer which does it correctly. And basically, as a developer, what you try to do, or what you would hope to do, the standard library helps me write. The JavaScript standard library is pretty crap, and basically for stuff like this, it had 3 functions which are somewhat, or look somewhat related: escape, encode UI, and encode UI component, and they all don't do what is required. They all escape some of the characters, but not all of them. And it's really easy to basically use one of those functions, change a tiny surrounding character, and now it's insecure again. So basically, the standard library isn't of any help. So what do developers now do? Yeah, everybody knows regular expressions, right? It's super easy. And there's this famous saying, if you have a problem and you use regular expressions, you have n+1 problems. And here it's even worse, because basically parsing like a string with regular expressions is okay, but HTML is not a regular language. You can't parse HTML with regular expressions. You need a real parser, and parsing HTML is actually really, really complicated, because due to the parsing particularities, it's fairly restricted how you could write even such an HTML parser. It's really complex. And yeah, exactly, depending on text, you basically have to go back in time and remove some stuff from the parsed string. And with regular expressions, you can't parse HTML. So basically, to sum up the introduction, it's very difficult to sanitize HTML by hand. It's basically pretty much impossible, I would say. And you don't have to trust me on this. Google had a report on trusted type adoptions, which is a cross-site scripting mitigation I will come back to later, which says, yeah, more of half the client-side cross-site scripting issues are due to sanitizer bugs. And yeah, they call it domics, it's the same. So we were interested, we're academia, right? We want to write a paper, and what we were interested is, are people actually using sanitizers, or are they still basically just putting everything back into the website? And if they're using a sanitizer or writing a sanitizer by hand, do they actually manage to do it properly? And basically, we set up a large study, which consists of 4 parts, which I will go through quickly. And basically, to understand the data collection part, I will shortly speak about Project Foxhound. This is a Firefox fork, which does dynamic time tracking, which is basically dynamic analyzers for JavaScript code. And what it sets it apart from other taint engines is it also records all operations that happen to some tainted value during the program execution. So we actually get really, really deep insight into how the application works, what the developer did, and basically can reconstruct a lot of stuff later on. And yeah, a bit of advertisement, it's open source, it's actively maintained, it's compatible with automated crawling frameworks, but you always will run an outdated version then, because it's not always up to date with mainline Firefox, but for security testing, it's a really great tool, I believe. The URL for GitHub is on one of the last slides. And with the taint browser, we can basically start collecting data, and we collected from the top 20K websites based on a Trunco list, all data flows which were somewhere related to client-side cross-site scripting. And basically, based on this data collection, this occurred on roughly 20% of the domains. Like we did in a zero interaction crawl. If you do basically basic interaction with the website, you probably get a much higher number, but it's then difficult to automate properly. So we have this taint flows, and they basically look like this. you have basically a string, like letters here, and the 4 shaded letters are the tainted letters. And the box above is basically the taint flow, and it contains a sequence of operations which basically happen to the string. And you can basically see how the string was basically manipulated throughout the execution. Now we wanted to extract the part which does the sanitization, and we basically reconstructed the call graph from this taint flow, and then basically tried to see what's the sanitization function and basically focus simply on that to not basically analyze the whole application logic, because then it would be completely infeasible to run it. And then we basically transformed it into an abstract representation, which is then the input for the analysis step. And here the question is the sanitizer actually secure? Our abstract model was then put through Semitech, which is a framework which does basically symbolic string analysis. You can basically, with a sanitizer, you can compute the automaton which describes the output of the sanitizer. So every word which ends in an accept state in this automaton is something you can generate with the sanitizer for an unknown input. As we know, cross-site scripting payloads, which you would require for the context the injection took place, we can then check whether this payload basically is part of the language of the sanitizer, and if that's the case, it's vulnerable, because there has to be some input which basically leads to the output we want to have, the cross-site scripting payload, after sanitization. So just saying something's broken and then going home is clearly insufficient. What we also wanted to do is basically to figure out what's the input we need to put into the web application to gain code execution. And for this, Semitech also allows you to basically run this computation backwards, and then you get the so-called pre-image, and as you can see, it's shaded in the back. It's really large usually. And it's basically also an automaton. It describes basically the language, or every word that ends in accept state will basically yield the payload you want to get. So if you basically just traverse the automaton, take a word which is accepted by the automaton, put it into sanitizer, you get bypass. For the example before, the bypass would look like this, and it again has added the angle brackets as before. And yeah, we then again visited the website with basically the bypass we calculated and checked whether it executes or there's some different application logic or restrictions which prevented this from basically executing. So we had a complete exploitation, basically pipeline, which allows you to put in a list, and afterwards you get a list with broken sanitizers and how you bypass them, and you can simply click the link and basically check them for yourself. Yeah, the results were roughly 4K domains had interesting data flows. On those, we found 705 unique sanitizers on 1.4K domains. So a lot of domains actually don't use sanitization. That was a bit concerning. And of those 705, we found 88 to be insecure based on our automated framework, like with zero manual interaction with the sanitizer or analyzers. And those occurred in 102 domains. And when we started the study, my expectation was the graph would basically be the inverse of the graph Marius showed. Like less popular websites are way more likely to be insecure because Facebook or Google have security teams, and my personal website doesn't have a security team, right? This wasn't the case. The websites we found which were affected are websites most of you have probably used to basically do banking or buy furniture in Europe. And we were basically, even for the validated one, which is the red bar at bottom, this was pretty evenly distributed, which was very surprising to us. And yeah, I will basically show some examples because it's probably the best way to learn how not to do it. And yeah, sanitizers, or hand-written sanitizers don't work against client-side cross-site scripting. And the first one is pretty nice. I believe that's a funny one to basically lighten the mood a bit. What the person here does, it's first, yeah, delete all single quotes, okay. Then delete all parentheses, that's reasonable. And then the most dangerous payload you can execute is also deleted. It's probably the person has no idea about security, got a bug report, this proof of concept exploits the website, fix it please, and had no idea what was actually happening why this is an issue. And yeah, the first thing is real hackers don't use alert. You can use confirm. And deleting parentheses to prevent function calls sounds at first like a reasonable idea. Like if you prevent function calls, it's much more limited what the attacker can do. But it's JavaScript, right? And JavaScript is crazy. You can also call it like this. I'm not 100% sure why it works, but it works. And so you don't need parentheses or single quotes to call a function. And there are tons of other ways to call functions without parentheses. Gareth Hayes from Portsbigger has like a new way every other week on Twitter. Yeah, JavaScript is full of tiny surprises. The next one is a sanitizer, which actually is not bad, but it's simply used completely wrong. What the sanitizer does, it encodes all angle brackets, which is a good idea for the HTML context because you would have to insert a tag. But if we look where the basically payload ends up in, it's inside the source attribute of an iframe, and basically you don't need a tag to gain code execution. You can simply break out of the source attribute and add another attribute, like an event handler. So a payload like this would work, and it doesn't need angle brackets at all. So the sanitizer works for some context, but it's applied completely wrong. That's probably the main issue, even with the ones we found, which were secure in the way we basically found them. If you change the surrounding code a tiny bit, they're completely pointless and broken again. Then people try to do block listing. I'm not quite sure how they came up with this. And what it does is first delete all image tags with their content, delete all anchor tags, and delete all script tags. Okay, you can do this, but block listing is super brittle by nature pretty much because the standard is evolving all the time. And new tags, which basically have attributes, ways to gain JavaScript execution, are added frequently. And the HTML specification is kind of strange. For example, you can simply write image, and the parser will translate it to IMG for you. The standard says you shouldn't ask why this is the case. It's a bit unclear, but yeah, it works the same, and the parser will fix it up for you. Also, the person tried to remove closing tags, and that's completely broken as well, because despite closing tags, attributes don't make sense if you have a closing text. The standard says, yeah, I'll accept those and drop them later on. So everything here about the sanitizer is basically wrong. It even broke the minted syntax highlighting. Another one is basically somebody who didn't really understand how regular expressions work, because first of all, again, script, anchor, and image tags are deleted. I believe probably some Stack Overflow which recommends those 3 tags, because a lot of sanitizers focus only on these. And yeah, regular expressions do a single scan over the input, and you can basically circumvent such a sanitizer simply like this. You add an anchor tag as a nested tag, and the regular expression would remove the anchor tag, and the script tag remains. So you basically can't sanitize nested tags unless you delete pretty much everything. And afterwards, the person tried to remove additional dangerous characters. That's a good idea, especially as injection context, again, some attribute of a script. However, as shown before, replace in JavaScript doesn't work like most people expect. I make this mistake all the time if I write JavaScript code. It's like, I don't know any other programming language where it's like this. If you basically call it with a string as first argument, it only replaces the first occurrence. And if you want to replace all occurrences, you have to either pass a regular expression with a global flag or use replace all, which I learned about yesterday, apparently. But nobody uses replace all. So a lot of people make this mistake. This was probably the most frequent mistake we encountered. So sanitization or writing a sanitizer is really hard. So what can you actually do? I will present 3 approaches on how to protect yourself, 1 which doesn't work, and 2 which may work in the future. The first idea is, if you basically follow the talk and it said you regular expressions don't work, you could say, yeah, use a real HTML parser I know, Yak or Flex, and can write a real parser and then follow the specification and sanitize the input properly, because it's much easier then. The issue here is HTML parser library. There you will get in trouble because are you sure that this parser actually behaves like your visitors' browsers? You have visitors with Firefox and visitors with Chrome, and even those browsers diverge pretty heavily in some cases, and usually in the security-sensitive cases. And this can be used to basically abuse parser confusion, like two disagreeing parsers to bypass a sanitizer. I will show some example here and go through how this works. You have a payload which is simply a select tag followed by an iframe and followed by a script tag with some basically JavaScript code. And if you put this in Google Kaya, which is a client-side HTML sanitizer, it's deprecated, but it still has 70K downloads weekly on NPM, so you can't delete stuff off the internet. It's parsed like this. You have a select tag, you have an iframe tag as its child, and then you have a text node which contains the cross-site scripting payload. And Google Chrome, on the other hand, parses it as a select node, and below it's a script node, which is executed. So Google Chrome apparently deletes the iframe, which is not really intuitive, I would say. And this another large issue. The HTML standard has some basically disagreements internally. I tried to basically figure out why this is the case, and I looked at the iframe element, and it says it can't have any content, like it can't have text children nodes. So Google Kaya is doing something strange because they put the script as a text node, but if you basically scroll 200 pages further, the parsing specification for iframe says, yeah, its context is a text node, despite that being not allowed. Unsure why it's the case, but so, for example, if you try something like this, you would get an iframe with a text node with image tag and no code execution. So in this case, the Kaya thing is actually correct, but the iframe is gone in Chrome. Why is this the case? When you recall the payload, there's the select tag first, and if you look again at the select specification, it has a very restricted amount of text which can appear as child nodes. And for example, it can have option, opt group, and script supporting elements, which are script and template tags. Yeah, iframe is obviously not opt group, script, or template. And Chrome says, yeah, that's invalid, I will simply delete it, and basically then lift the script node up to something that's executed. And this is basically meant to highlight how difficult it is to parse HTML correctly, even if all browsers would agree, because very often you have basically to decide on the context, what happens with a tag. Sometimes you have to delete it, and stuff below will change, sometimes stuff above will change. It's like really complicated. And yeah, exactly. Basically, sanitization based on a full HTML parser need to take into account that there are several browsers, and the browsers diverge in between each other, and that the specification has a ton of edge cases which are scattered around of this 5.k page document. Some stuff is only in the error handling, and HTML parsing has no error handling, like they do strange stuff, but you would never get an error, basically. It always repairs broken input for you. And it's a really tough task to write this by hand. And yeah, exactly, if you have Chrome visitors and Firefox visitors, even their parsers will disagree in a lot of cases. And what's important is this also applies to server-side HTML sanitization. And I would say server-side HTML sanitization is impossible unless you are basically willing to throw away most of your input, because they're tags which you can't sanitize on the server because their behavior is dependent on properties of the client. So HTML parsing is insane, and yeah, server-side HTML parsing is even worse. So I've told you that most of the stuff is broken, and the question is how to protect yourself. First of all, don't write a dynamic website. If it's static, no JavaScript, then you're fine. So basically, the idea is to minimize putting user input back into the DOM, but that's not really feasible, right? You want a dynamic website. The second suggestion is avoid HTML markup injection, because the trouble basically starts as soon as you want to basically allow some text. If you want to say, yeah, formatting is nice, but don't allow scripts. That's where the trouble really starts. And what you can do is you can use BB code. That was all the rage when I was a bit younger. And these days it's probably Markdown or similar stuff for formatted input. And then you can basically get rid of sanitization and encode stuff, which is much easier. But yeah, if you have listened to Sohail yesterday, basically markup has then to be converted into HTML, and then you have maybe room for DOM clobbering. So it's yeah, complicated. The third suggestion is to use a well-tested library. Like there's DOM Purify for client-side sanitization, which is basically pretty much the gold standard so far. If you use this, you probably best-in-class protection. And you have to keep it keep it frequently up to date, because sometimes there are bypasses despite really, really smart people working on DOM Purify. But it's the problem is so complicated that even they have bypasses somewhat frequently. And this is pretty sad state of affair because, yeah, some of you are RuhrSec veterans. There are XSS talks for every iteration, I believe, pretty much. Client-side XSS is known for like almost 20 years by now, and we still haven't figured out how to get rid of it. And currently there's some movement in the space, and there are two upcoming browser features which are both draft specifications, the Sanitizer API and trusted types, which I will explain yeah, shortly. The Sanitizer API is actually, I believe, the more promising one, and Google and Chrome and Microsoft have committed to it. Safari, it's a bit unclear. And the idea is to basically add a robust and secure by default HTML sanitizer to the JavaScript standard library. And that's great in my idea. It's updated with the browser, so even if there's an issue, you will have auto updates unless you use like server-side browsers. But then you have other issues as well. And you use it basically like this. You create a sanitizer JavaScript object, and then you can basically directly assign sanitized HTML to a node. This either works like this with set HTML, or with sanitize for, you have to give a context, because if you recall the select case, how the pathing works changes a bit on the context where it's inserted, and then replace the children. And afterwards, on error handler is dropped. If you basically have written JavaScript code in the past, this code will look pretty unfamiliar, I believe. You can't do string manipulations with it. And yeah, the positives about the Sanitizer API is it's secure by default. It basically is very hard to use in a wrong fashion. You have to really basically be crafty to get insecure, or to use it in insecure fashion, which is a good idea because secure by default is great. And it uses the same HTML parser as the browser. This means it will always behave like Firefox or Chrome in the current version you're using, so you never have any parsing divergencies. However, it enforces the security properties via its API, and it doesn't allow for string-to-string sanitization or manipulation. And this is actually not how applications are written today. I've looked for this talk at a lot of basically data flows, and a lot of the websites in wild do sanitize somewhere in the middle and then add some text in the end, prepend some text, and that's pretty much impossible with the Sanitizer API without losing security guarantees and without rewriting the application, which, yeah, I believe it won't get much uptake because for legacy applications, you have to rewrite most of your stuff. And yeah, companies don't really like this. And it's still under development. You can't basically roll it out for productive usage without like polyfills and stuff to support legacy browsers and Safari. The second draft specification is trusted types, which is like a Google initiative. And here the idea is to ensure that sanitization has taken place, that you can't forget to sanitize input via the type system. I really like strong typing, so the idea is pretty nice, I believe. However, it's currently only supported by Google and Microsoft, but yeah, they make up most of the browser market share. And the idea is basically every sync function which does string to code transformations accepts only trusted values and rejects string parameters. And you basically have to convert your string into a trusted value, otherwise you get a type error. So you can't assign strings to the sync anymore. However, it's hugely invasive, like in HTML is used on every website pretty much with string arguments. If you simply change it tomorrow, the whole web would be broken. And yeah, they're aware of this, Google aren't stupid. And what they do is they allow you to basically opt into trusted types, and this is done via content security policy, which will probably kill this feature, because piggybacking onto another feature nobody can use is probably not the best start. And yeah, you can basically say all sync access has to go to the trusted types thing first. And if you have rewritten your website or adapted your website to trusted types, then it will work. And if you haven't, then without the content security policy, nothing changes pretty much. And you would use it basically like this. You have to create a so-called trusted types policy. And the policy contains a set of sanitizers. I've only shown the HTML ones here. There are ones for JavaScript and URLs as well. And basically, if you want to assign something to in HTML, you have to use the policy first to create a trusted HTML type. And then the secure assignment and works as expected. If you do a direct string assignment, it's insecure and gets a type error, and basically the execution will halt. You might have seen the problem already with this approach. Enforcing sanitization is really good, I believe, but it makes zero suggestions about the sanitizer itself. Like every one of the broken ones I've shown you, like removing alert tags or the alert keyword could be used as a trusted types policy. In fact, this might be more advanced than most trusted types policy that are out there in the wild. I believe like roughly 90% we have seen so far are basically return the input without manipulation. So the type error goes away, which can make sense in some cases, but I believe not in the cases we found most. And they require a very generic sanitizer. Like you can't have context information, so parsing gets really difficult. That's one of the reasons why Mozilla says that they're not keen on supporting it. And it's pretty much unusable for normal people. It has some undocumented parameters, which apparently make your life much easier, but you only get to know them if you basically use a debugger and know Google people. So it's a Google-only technology, probably. And if you're interested in usability of trusted types, Sebastian Roth, who gave the talk yesterday, has probably much more insights there than me. They're working on this currently, but yeah. And yeah, as I said, it's only Google and Microsoft at the moment. And what I really like about their approach is the basic ideas. They say, yeah, we won't fix the web as is, but they're currently paying people to basically fix up frameworks like Angular, React, because the assumption is, yeah, most new modern websites are written with such a framework. Few people still basically write HTML manually and basically write all their JavaScript code by hand. And they pay basically Google engineers to support trusted types in Angular or React. And if you then update your framework, you basically get trusted type enforcement for free, and the application is more secure. Like that's a really nice idea because the website owner doesn't have to do anything, but Google will basically passively fix some issues for you. So the key takeaways, it's 2023, and client-side cross-scripting is still an issue and will probably be still around for the next 5 to 10 years, I would say, at least, probably more. The sanitizers we found, and especially the ones which weren't flagged as insecure by our framework, are not really generic. That is, you don't remove every input which might be dangerous in the injection sync, nor very context-specific, like they always remove like 50% of the dangerous stuff. So if you have a very small change in the surrounding code, the application suddenly becomes insecure. So most applications where we found a sanitizer where we said it's not vulnerable as is probably one copy and paste error away, or one copy and paste away from basically being broken again. So the numbers I basically reported are pretty low, but it's a lot more problematic in the real world, I would say. You have First-party sanitizers are way more likely to basically be broken than third-party ones, which makes sense, because third-party ones are like content delivery networks, frameworks many people use, whereas first-party ones are usually ones only occurring on one website and basically being written by hand, and yeah, that doesn't work. And developers don't actually understand JavaScript, like encoding functions is completely unclear apparently to a lot of developers. They don't really understand regular expressions and like the standard library, even basic stuff like replace. But that won't be fixed, I suppose. And yeah, I want to thank you for your attention. And here are some links for basically the open source implementation of our stuff. If you're interested in like Foxhound, please get in touch. We're super happy to help you collaborate or get started. We would really like to basically, if more people would use Foxhound. Yeah, I'm open for questions.